We're going to do a quick little review on area of polygons. So we're going to look at parallelograms, triangles, and trapezoids. So first off, looking at parallelograms. Parallelogram is a quadrilateral, meaning it has four sides, with opposite sides that are both parallel and congruent. So in this parallelogram here, these sides are congruent, so that side's congruent to that side, but it's also parallel, which I'm going to show kind of with a little arrow. And this top side is congruent to this bottom side, and they are also parallel to each other, so they never intersect. So it is two sets of parallel and congruent sides. Steps to finding the area of a parallelogram. You need to identify the length of the base and the perpendicular height. So that is the most important part here. When we look at this parallelogram up here, we need our base, which could be this side, could be over here too. They have the same exact measure. But then we're looking at the height, not the side length. We're looking for the perpendicular height that meets at a 90-degree angle. Once we have identified the length of the base and the perpendicular height, we're going to use the formula area equals base times height. So in this first one, the first thing that I am identifying is that perpendicular height. So I'm looking for that 90-degree measure. And then I'm saying, okay, well, what side measure is that perpendicular? Where does it meet with the 90-degree angle? With this side, well, there's no measure here, but I know that the opposite side is the same measure. So we have a base of 20, a height of 3. I want to see what you plug in. 20 times 3, which gives me an area of 60. We are talking about units of centimeters, and area is always squared. So 60 centimeters squared. For example 2. Again, first thing I'm looking for is that 90-degree angle, which I see right here. And even though this is technically outside of the shape, where does it match up with that 90-degree angle? It matches up with this side right here. So my area is my base of 11 times my height of 8 7/10. If you want to, you can use a calculator, and you get area equals 95 7/10, and again, our units, centimeters squared. Working backwards, finding missing values. What we're going to do is we're going to plug all the known information into that formula that we have, area equals base times height. Then we're going to solve the equation for the missing value. So find the height of a parallelogram with an area of 131 22/100 inches squared and a base of 8.1. So we're plugging into this formula, area equals base times height. Well, the information that's given to me, I'm given the area and I'm given the base. So I'm going to plug that into my equation. Got my area of 131 22/100 equals my base of 8.1, and we are solving for the height. So that's my unknown. Then I want to solve the equation. I look at the side with the variable. It's being multiplied by 8.1. The opposite is to divide by 8.1, and I'm going to show my work as so. Use my calculator. 131 22/100 divided by 8 1/10 is 16 2/10 is my height. But what is my units? We're talking about inches. Height is just inches. It's not inches squared. So it's 16 2/10 inches. So that's parallelograms. Let's look at triangles. So a triangle is a plane figure with 3 straight sides and angles. When we are finding the area of the triangle, it's the same exact thing as for parallelograms, that we're going to identify the length of the base and the perpendicular height. So just like before, we are looking for not only the base, but we're not using all side lengths. We're looking at, okay, according to that base, what is the height that is perpendicular to it? And it could be on any side of the triangle. So like these 3 examples here, we have our bases, and then the height isn't always going to be straight up and down. It just depends on what 2 they connect to. And then the formula, either we're going to use area equals base times height divided by 2, or that's the same thing as if we've got fractions, 1/2 base times height. They mean the same thing. So let's go ahead and look at an example. We first want to identify that height, because that's going to tell us which of the 3 side measures we need. So here is where I found that 90-degree measure. Well, what side does that connect to? It doesn't connect to the 6, it connects at a right angle with the 2.3. So I'm going to plug it into my formula. Area equals my base of 2.3 times my height of 5 44/100 divided by 2. And I've got a calculator to do the work for me. And I get an answer of 6 and 256,000, so maybe I'll round that to 6 and 3/10. And now we're talking about area, so centimeters squared. Example 5 over here. Again, first thing I'm looking for is that perpendicular height. On what side does that connect to at a 90-degree angle? It connects with this side here. So plug in that information into our formula. Area equals our base of 3 times our height of 10.5 divided by 2, which gives us an area of 15 75/100. Again, if you want to round that, you could round that to about 15 8/10 millimeters squared. Working backwards, a little bit trickier. People tend to make mistakes with this because it's similar to parallelograms, but the half divided by 2 is what messes people up in this. So to find the missing values, we plug all known information into the formula. Area equals base times height divided by 2, or 1/2 base times height, either way. Then we're going to solve that equation for the missing value. So looking at this problem here, find the height of a triangle with an area of 39 2/10 meters squared and a height of 5 6/10 meters. So, got our key information. We're given the area, we are given the height. And this actually shouldn't say find the height, it should say find the base. So let's plug in what we know. We know that our area is 39.2. We don't know the base. I know that my height is 5.6 and that whole side is divided by 2. So really what we got to look at is the last thing that's being done to the variable here. It's not being multiplied last, it's actually being divided by 2. So that's where we have to work backwards from. That's the first thing we need to do. Instead of dividing by 2, we need to multiply each side by 2. On this side it'll cancel because that's like 2 over 1. If I multiply the right side by 2, I need to multiply the left side by 2. And this is where a lot of people make mistakes. They tend to divide instead of multiply. They're not thinking about inverse operations. So we get 78.4 equals what's left over here, b, our base times our known height of 5.6. Now we're back to a basic equation. The base is being multiplied by 5.6, so the opposite is to divide by 5.6. And we're left with 14. So our base is 14 meters. And the last ones we're going to look at trapezoids. We're not going to do working backwards with these. We're just going to be figuring out the area. So a trapezoid is a quadrilateral. So it has 4 sides. They're similar looking to parallelograms with one difference. It only has 1 pair instead of 2 pairs of parallel sides. So like in this picture here, we have a set of parallel sides here, but these two aren't parallel because even though they're not intersecting yet, if we continued them, they would. Finding the area of trapezoids. Well, we're going to identify the lengths of the pair of parallel sides. These are our 2 bases. So we have 2 different bases here because they're not the same lengths. In a parallelogram, this side is the same as that side, so it doesn't matter which one you choose. We have to identify both since they're different. Just as before, we need to identify the height that is perpendicular to the parallel bases. And then we're going to use the formula. It's kind of similar to triangles. We do base 1 plus base 2 times the height divided by 2. Or 1/2 base 1 plus base 2 times the height. Either way, this one's going to be easier unless you have fractions in there. The reason we do that divide by 2 is we're actually kind of trying to find the average of these 2 bases. Because where they average, that's where they would meet, and that would be the actual base length that works. This would be too big, this would be too small. We're trying to find that middle ground. So let's look at an example. For example 7, we first want to identify, let's look at those, either the height or the perpendicular parallel sides. I'm going to identify my parallel sides. The 2 sides parallel are right here. And then the measure that is perpendicular to that for the height is that measure of 11. So let's plug it into our formula. Doesn't matter which one's base 1, base 2, as long as you're adding those 2 together. So we've got 12 plus 18 for our 2 bases times our perpendicular height of 11 divided by 2. So before I do any division, anything, multiplication, I have to add in these parentheses first. 12 plus 18 is 30, so 30 times our height of 11 divided by 2. 30 times 11 is 330 divided by 2, which gives us an area of 165 yards squared. And the last one, the parallel sides. These 2 are not parallel to each other, so it's these 2 right here that will not intersect. And then there's no dotted line that shows us to the height. Well, that's because this side right here is actually the perpendicular measure. So it does happen to be that the side is our height. So plugging into our formula, base 1 of 18 plus base 2 of 15 times our perpendicular height here of 7.3 divided by 2. So we have 33 times 7.3 divided by 2. So we get 240 and 9/10 divided by 2, which gives us an area of 120 and 45 hundredths feet square. And if you want to round that, you can.